Well, this will be our last example for the Cauchy-Euler theorem. I still have the little cheat notes on top for what the Cauchy-Euler theorem is, basically saying that this, we can find the solution to this and then do our substitution to convert the t's into x's, then we have the solution to this one. So we're going to solve x squared y double prime minus 4x y prime plus 4y equals this function, x to the 6th ln x. So our f of x is x to the 6th ln x. And as usual, x is equal to e to the t, and t is equal to ln x. So at the end, to turn our t's into x's, we're going to use these two. All right, so our coefficients, a, b, and c, are 1, -4, and 4. So the Cauchy-Euler theorem says that dy1, d squared y dt squared minus, the minus 4 comes from b minus a. That should be, let's see, that looks like it should be a minus 5. This should be a minus 5 because it's b minus a for this coefficient from the theorem. Minus 4 minus 1. Here's the theorem. Plus 4 times y is equal to what? It's got to be in terms of x's now. So x to the 6th is e to the t to the 6th, which is e to the 6th t. ln x, well, that's simply t. Okay, so now we have the equation in this form, and now let's solve it. I'll go ahead and put a box around it. And as usual, the first thing we do is the homogeneous, which is going to be take the characteristic equation, m squared minus 5m plus 4 equals 0. So we have two negatives. So I'm going to have minus 4 and a minus 1. Took me a while there. -1 times -4 gives us that, and -1 plus -4 gives us that one. So setting those equal to 0 gives us m equals 4 and 1. So that tells us what our homogeneous solution is of this differential equation. C1, e to the t, plus C2, e to the 4t. So I'm calling the 1 because of this, 1t because of this one, 4t because of that root. So I'll go ahead and put a box around the homogeneous solution. Now let's do the particular solution. Okay, I need a lot of room. I'm going to get as much as I can right down here. So for the particular solution, what are we going to choose? What are we going to try? Or guess, I usually call it. We could use that table from the textbook, but t is a polynomial, a degree 1 polynomial, so it's like a straight line. So I'm going to have to do something like at plus b. And then e to the 6t, I'm just going to keep it the same, e to the 6t. So we will guess y particular is equal to at plus b. That's because of this t. That's a generic first degree polynomial times e to the 6t. And I'm going to go ahead for simplicity now. I'm going to multiply it out and get at e to the 6th t, e to the 6t, plus b, e to the 6t. I'm going to put a circle around that. Do I have room? I don't think so. Now we need to get derivatives. Y sub p prime. The derivative of this guy, so it's going to be the derivative of the first, AT, times a second, plus a second times the derivative of the first. And I've got 6AT e to the 6t plus AE to the 6t plus 6B e to the 6t. And I'm going to regroup that so that we get 6AT e to the 6t. And then these are like terms. They both have e to the 6t. So I'm going to take the a plus 6b times e to the 6t. And that's my y prime p. And the y double prime p. If you don't mind, to save one line, I'm just going to go straight to the simplified version of it. So we're going to take the first times the second plus the second times the first plus the first times the second plus the second. Well, the first times the derivative of the second plus the second times the derivative of the first. And likewise over here, combining like terms, we get 36a t e to the 6t plus, in parentheses, 12a plus 36b times e to the 6t. All right, so this thing right here, te to the 6t is equal to all this. I'm going to put that first. Te to the 6t. Let me put, so we know we're starting something new, I'm going to put so te to the 6t is equal to y double prime p, this guy right here, 36 AT e to the 6t plus 12a plus 36b, in parentheses, e to the 6t. That is my y double prime p. I'm just making a note. Because now I'm going to put plus -5 times dy times y prime here. So I'm just going to multiply this whole thing by -5. This whole thing, and it'll give me -5 yp prime. So that's going to be a -30 at 6e to the t minus, multiplying by 5, 5a plus 30b, in parentheses, e to the 6t. And that's a -5 yp prime. This goes with this row, this goes with that row. And then plus 4 times y. Well, y is just this guy right here. So it's going to be 4at e to the 6t plus 4b e to the 6t. So plus 4at e to the 6t I don't know what this is. This is 30at e to the 6t. I erroneously wrote the 6 down as a coefficient. Okay, and then to finish this one up, plus 4 b e to the 6t. All right, to summarize that, simplify that, and t e to the 6t, and I'm just adding all the like terms together. We're going to get 10 a t e to the 6t plus, in parentheses, 7a plus 10b e to the 6t. So I'm going to go ahead and put a box around it, but it's not our final answer. All right, so what can we do with this? Well, we can figure out a few things here. We can figure out what a and b are. We know that this term, this is a t e to the 6t. Here's a t e to the 6t. And there is no just e to the 6t term on the left-hand side, so we're going to get two equations. We are going to get t e to the 6t. 1 equals 10a. The coefficient in front of this is a 1. The coefficient in front of this is 10a. So that gives us a equal 1 over 10. And this has to be equal to 0. There's nothing over here corresponding to that. So 7a equals plus 10b equals 0, but we know a is 1/10. So that's 7 times 1/10. 7/10. Looks like it's going to be negative 7 over 100 if you solve for b. All right, almost there. I'm going to get one more line down here, and the final answer I'll put up here. So yp, particular, I'm going to put of t just to remind ourselves that we need to change it to y of x in just a minute, is equal to, in parentheses, 1/10 t minus 7 over 100 times e to the 6t. That's coming right from here. And then we're going to here. That's the particular, which implies that yp of x, all we need to do is the substitutions. What is t equal to? ln x. What is t equal to? ln x. So this would be like e to the 6 ln x, or e to the ln of x to the 6th, which is just going to give it x to the 6th. So I didn't write all of that down, but we've done this kind of stuff before. So we're going to get the particular solution, in parentheses, is ln of x over 10, ln of x, excuse me, all over 10, or I could have said 1/10 ln x, minus 7 over 100, in parentheses, x to the 6th. That will get a box around it, and a star, because that, along with this, which I'll put another star, those two stars give us the general solution. The general solution is yh plus yp, so our general solution, I'll even use a different color, is y equals, first is the homogeneous, c1 e to the t, plus c2 e to the 4t, plus the particular. I'm going to write it on the next line just to make sure it's visible. 1/10 ln x minus 7 over 100, all in parentheses, x to the 6th power. A rather long problem, but most of the time it was just doing the differentiating and the algebra to combine like terms and all of that. So that concludes the Cauchy-Euler Theorem and examples.